Hello grade 12, welcome to my channel. Hopefully you wrote your exam very well. I hope you are well prepared and that the channel was able to assist you here and there. Let's just review this question 1 from the paper you just wrote, hoping that you guys scored all the marks just to ascertain you, basically. So let's go. 1.1 is the standard question where we solve for x in quadratics, essentially. So we've got 3x squared plus 5x is equal to 0. Then we solve here by taking out the highest common factor, which is x. So we remain with 3x plus 5 is equal to 0. Then we can conclude that our x is 0 or our x is minus 5 over 3. Okay, so don't be too excited you got an answer. These simple questions have a tendency to go wrong, so we need to check our solutions. Now if we plug 0 there, we know that the left hand side is equal to the right hand side. Then we plug minus 5 over 3 there, that gives us 25 over 9. Okay. And then 3 goes once to itself, it goes 3 times 2, 9. So that's going to be 25 by 3, that's 75. Okay. And then we look here again, we will see that we will have 25 over 3, basically. And what did I say here? Yeah, it's gonna be, wait a minute. What are you saying here, sir? Yeah, man, this is gonna be 25 times 3, but leave the 3. The 3's will cancel the 9, so it's gonna be basically 25 over 3. And then here we get minus 25 over 3. That gives us 0. So essentially those solutions hold. So it looks like those are the only marks on offer. Okay, easy stuff, but don't take it too lightly. It can embarrass you. 4x squared plus 3x minus 5 is equal to 0. Now the guide is corrected 2 decimal places, already telling us that our x is not going to be easy to solve because the roots are not rational, meaning our discriminant is not a perfect square. So we need the quadratic formula for this, which is effectively completing the square, right? Right. So let's see, this is minus 3 plus or minus the square root of 3 squared, 4 into 4 into minus 5, 2 into 4. Therefore, our x, let's check on our calculator, our lovely friend, minus into 3 plus the square root of 3 squared minus 4 into 4 into minus 5, 2 into 4. Don't be too much in a hurry though. This is 0.80, or x is. So make sure you are meticulous on the substitutions because these are essentially free marks, isn't it? These are marks for free, guys. You're not sweating. You're just going through the motions. Now let's check. Remember, don't be happy you got to the answer. Check on the original that the equation is satisfied. Now we can see the roots were irrational, so by rounding off, we were rationalizing these denominators. So essentially, we want to round off to the nearest integer there. Okay, we've got 4 into 0,80 squared plus 3 into 0,80 minus 5. Now rounded off to the nearest integer, it's essentially 0. So that is correct. And then let's look up the other ones. So don't be lazy, guys, to check, because these are marks you should just take with confidence, honestly. But you cannot be confident if you did not check. Not checking is suicide. So I'm getting the same answer. Rounded off to the nearest is effectively 0. So that means our substitutions are on point. So those are the 3 marks on offer in this question. Alright guys, so let's move over without wasting time. 1.1.3. So we've got x minus 1 all squared minus 9 is greater than or equal to 0. We can see this is the vertex format of our parabola, but we need to expand it so that we can work it out nicely. So this is going to be x squared minus 2x plus 1 minus 9 is greater than or equal to 0. This implies x squared minus 2x minus 8 is greater than or equal to 0. We can then find our critical values by factorizing. This is minus 4, this is plus 2. Okay, we're not really solving for x, are we? We just want a graph. So we're going to use the graphical method here on a Cartesian plane. So we can see that our coefficient of x, which is our a value, is a positive answer. So that is good. So our one critical value is negative, one is positive. From the vertex format, we can see our axis of symmetry is on the positive x-axis. Our y-intercept is minus 8. Our minimum value is minus 9. So our graph is doing things like that. And we know that at the y-intercept it's minus 8, and then we know that the turning point is literally 1, is to minus 9, and we've got 4 there, we've got minus 2 there. Alright, so I always assume a very perfect sketch, guys, but you know what? Do whatever you are taught and it seems to work. So where is this graph greater than or equal to 0? We can see that our graph is equal to 0 at x is equal to 4 and at x is equal to minus 2, and these are included. But we'll see that as we read our graph to the right of these critical values going to positive infinity, the graph is positive, and going to negative infinity, the graph is positive. In between, it's negative. So the solutions are literally lying in this field here. Okay, those x values. So we interpret this by saying x must be less than or equal to minus 2, or x must be greater than or equal to 4. That is how this is done. So 1 mark for each, and for getting our critical values in a way, and perhaps writing our equation in standard format. I wonder if it was necessary, because this is also a standard format of the parabola when it's given in the vertex format. So perhaps that mark could come for the tool that gives us the solutions. Doesn't matter how those marks are scored, we have them. Alright, so 1.1.4. So we've got 5 to the exponent 2x plus 5 to the exponent x is equal to 0. This implies if we apply our exponential rules, we know that when we multiplied powers with the same bases, we simply added the exponents. Great. So just bear in mind that this is a power as a whole with a base and its exponent. Now let's go on. We are going to factorize here, taking out the highest common factor. We get 5 to the exponent x plus 1. And this is equal to 0. Look at me. Be very careful on how you copy these expressions. A very simple lapse of judgment can end up with the wrong sign somewhere. Therefore, we know that here 5 to the exponent x is equal to 0. And we know there's no such a thing. There is no power that is equal to 0. The power is either closer to 0, but it never goes to 0. So 0 is an asymptote, essentially, or a horizontal asymptote for that matter. Okay, so that is the case, or 5 to the exponent x is equal to 1, which implies that 5 to the exponent x is like that. So using again exponential rules, then we can conclude that our x must be 0. Very interesting equation right there. Alright, so how many marks are on offer here? 4 marks. Okay, so I'm sure rejecting that is important because this is algebra, so any rejections are quite important. That answer should be important. And essentially the factorization is important. Perhaps employing exponential rules to split that power into 2 powers, the same basis and the same exponents. But remember, don't be excited you got the answer, guys. The answer could be wrong. Check the answers on the original. Now what happens when we put a 0 there? We get 5 to the exponent 0, which is effectively 1. Again, 5 to the exponent 0, that's 1. 1 minus 1 is 0, so the left hand side equals the right hand side. This one is already sorted because we know there's no power that is effectively equal to 0, no matter what value the exponent takes. Okay, easy stuff. So we've got that 4 marks in the bag. Okay, let's go 1.5. We've got x divided by the square root of 20 minus x is equal to 1. Okay, this implies that we've got x over the square root of 20 minus x is equal to 1 over 1. Then we cross multiply. This tells us that x, perhaps let's bring it a bit closer to the equal sign, is going to be that square root of 20 minus x. Here we do reverse operations because we're trying to reverse the square root sign. This gives us x squared is equal to 20 minus x. Then we put this in standard format. It's going to be x squared plus x minus 20 is equal to 0. We then factorize. What do we get? X plus 5 minus 4. Therefore, x must be a 4, or x must be minus 5. Now let's see. Don't be happy again, you got an answer. Check these solutions, whether the left hand side is equal to the right hand side. But for this one, the checks are in two format. We want the left-hand side to be equal to the right-hand side. The second check, we must not have a negative under the square root sign. Okay, so that is not allowed. So let's see. We put a 4 there. 20 minus 4 is 16. This is the positive square root of 20 minus x. So this means is the positive square root of 16, which is 4. 4 divided by 4 is 1. Then 1 is equal to 1. So this solution holds. Then we put a minus 5 there on the numerator already. That compromises the denominator no matter what happens. In any case, we get minus 5 divided by the square root of 20 minus minus 5 is going to be 25. Square root of 25 is 5. So minus 5 divided by 5 is minus 1. Minus 1 is not equal to 1. So that is the solution to reject. Again, rejecting that solution is an algebraic, mathematical, important issue and matter to really consider. And then we can give a mark for getting this quadratic in standard format, because in sad form or in the radical form, it's not standard. All right. Great. So 5 marks. Okay. 1, 2, 3, and 4 marks perhaps for doing our reverse operations here and essentially our factorizations. It became a bit generous. Usually 4 marks should be enough here. Okay. Not a big deal, guys. Let's get to the simultaneous equations. 1.2. Easy stuff. So we've got x plus y is equal to 9, which means y is equal to minus x plus 9. Put it in standard form, right? And we've got 2x squared minus y squared is equal to 7. That becomes our equation 2. So we put 1 into 2. What do we see? We'll see that we've got 2x squared minus, instead of y, we put minus x plus 9 all squared equals 7. This is 2x squared minus, we FOIL this out, it becomes x squared minus 9 is minus 18x plus 81 is equal to 7. 2x squared minus x squared plus 18x minus 81 is equal to 7. Then we sort this out, we get x squared plus 18x, so minus 81 minus 7 is going to be minus 88 equal to 0. Let's see if we can factorize this thing. X. Now we focus on this 88. So let's see, 88 equals shift fact. I get 2 cubed times 11. 2 cubed is 8. 8 and 11 gives me 19, so it's not working. Let's fashion it out. It's going to be 2 squared times 2 times 11. So this is 4 times 22. Now 22 minus 4 gives me 18, so that works. So I am going to make this one minus 4, this one plus 22. So guys, be smart, use your calculator as well. There's no excuse for not knowing how your calculator works. It just shows, if you don't know, that you are not serious about your work. Okay, that is the case here, let's see y is going to be, we take this and substitute into equation 1. So minus 4 plus 9, that's a 5. Or y is minus into minus 22, that becomes a positive 22. Then 22 plus 9 is 31, right? Yep, 31. Now, again, same story. Don't be happy you got to the answers. Check the answers for correctness, okay? Now, let's put x and y. So we're going to put the corresponding x and y values here. So 4 plus 5 gives us 9. So the equation balances. So these solutions hold. Check on the original, not on the manipulated one. Maybe this equation 2 is original. You can check on it as well. So we put 31 there. And then minus 22. So 31 minus 22 is 9. So again, the equation balances when we take those corresponding coordinates. So these are the points of intersections of the two graphs. You can see this is a circle, literally, and a straight line graph. Okay, great. Now we've got our 4 marks. How many marks? 5. So 1 is for the substitution into the other. So can you see, guys? You can see exactly that these marks are yours. So you're walking away with these marks. Now let's do the last one, 1.3. So this is a bit naughty. They always bring in these silly questions here. We've got P equals 1 minus A, and T, which is given by this lousy and confusing expression. Okay, maybe lousy is not the appropriate word, but it's just ugly and scary. It's one of those questions that are here to cause trouble. Okay, so we're given those. What are we supposed to do? We need to determine the value of P times T in terms of A. Okay, so we know that P times T is basically going to be 1 minus A into 1 plus A into 1 plus A squared into 1 plus A to the exponent 4, that continuing until that last one. Okay, great. So what happens here? You will notice that technically we've got a difference of 2 squares here. So we can do a reverse operation on that by contracting it. So it's going to be 1 minus A squared into 1 plus A squared into 1 plus A to the 4 into 1 plus A to the 512. Okay, again, another difference of 2 squares pops up. And then we contract that systematically. So this is basically 1 minus A to the exponent 4. 1 plus A to the exponent 4. And then this goes to 1 plus A to the exponent 512. So as we can see, we keep getting this difference of 2 squares. And as we keep getting them, we notice that this will affect the next term up until we get to that. So we can just easily jump from this step now. Once you notice the pattern, you don't mind. This is going to be 1 minus A to the 512. It's going to get there into A into 1 plus A. I don't know why I didn't leave a space. sometimes when these expressions are hectic. So this will end up with 1 minus a to the 512 multiplying 1 plus a to the 512. So all you needed to know was to notice this pattern. Every time you contract this, it affects the next time. It creates a difference of 2 squares with the next one up until the last one. So obviously a bit of bravery here is necessary. So now this one, we sort it up again. It's going to be 1 minus a 512 by 2 it's 1024. So that is a to the exponent 1024. And that should be the answer in terms of a, because we cannot simplify further than this. Alright, so it looked a bit silly, but it's what you call an NBT type of question, which is effectively a higher grade question. Because here you need to be brave, you need to be patient. One needs to be vigilant as well, or observant, because once something is set up nicely, take it down bits by bits, but you will see the pattern keeps on repeating itself, and this means we are going to get somewhere. All right. Great. So this is what happens here, guys. So let's just not complicate it. So the answer is a mark, and also knowing that eventually this boils down to this, it's important. And essentially, where's the other mark? Probably to show that this thing ends up in this pattern, maybe 3 marks, or for the rest of the work, I don't know. But I think what started this is here. So it shed the light that we're doing difference of 2 squares. Maybe we can say these 2 steps were essentially critical to notice, so we can give a mark for both of them, because then they told us that the pattern is in this manner up until we could end up here and find our answer. Alright guys, so this is how you would take these 26 marks with a smile. Can you see within 30 minutes you would have taken these marks without any issues whatsoever. Perhaps one that could give you a bit of a nightmare would be 1.3, but as soon as you notice this is a product, if you just be brave and plug it, then you will start to notice. Remember, inspection is very important. If you don't inspect the expressions given, you will never get an idea as to how to go about questions as naughty as these ones. And in the NBT, these are the most popular questions. Alright guys, have a good one. I will see you next time. Bye-bye.